You know that your data is in an Amazon S3 bucket and a Lakehouse and an ADLS v2 and somewhere else, and you need to create a report on top of all of this data. So today we talk about shortcuts. We will introduce shortcuts in a generic way, then talk about the capabilities and the limitations and the basic idea of all of that, and of course have some demonstrations in between. Let's have a look at the basic stuff. How does it work? What's the idea behind? So shortcuts are for unification of your data. So you can bring in your data into Fabric without copying the data. That's the main point. It works for files. For more complex data structures like other databases, you should use mirroring instead. But when you have a file-based data that you want to bring into Fabric, shortcuts are the way to go. We are talking about lakehouses. And in lakehouses, as you might know, you have two different folders. The first folder is the files folder. The files folder is like a generic place where you can put almost everything. You can create scripts, you can place whatever file you want. So it's a little bit like a generic storage. And you can, of course, create shortcuts here. So let's say you create a shortcut to let's say raw logs that points to your Amazon S3, AWS S3 storage. This is by definition read-only. Every external storage shortcutted is read-only, so you cannot write back. That's important. When you have it in the files folder, of course, you need some kind of logic to bring it or to elevate it to a table in the Lakehouse. But that's a different story. The files are in there. Next folder that you have is the tables folder. The tables folder. There you can also, of course, have your tables. So let's say you have your sales table. It's a simple table that you have created. You can place shortcuts here. So, for example, a product shortcut. And the product shortcut points to an other favorite lakehouse. A different lakehouse, you will have read-write capabilities there. And it's very, very easy because it's inside of your Fabric. You could also have something like this, an ADLS v2, Azure Data Lake Storage version 2. You could also point to that. No, my fault. The ADLS comes down here. So you could have like an, I don't know, customers table that points to the ADLS v2. This is to read-write because it's internal storage, which means same authentication scheme, right? But to get that as a table, it needs to be parked directly. We will come on that later. But you cannot put anything, I don't know, CSV, JSON or something like that to the tables folder. You could put it to the files folder, no problem. And then use something like a conversion notebook, something like that, to bring that up to a table. So why this design? It's like a virtual unification namespace. You can bring all your data from almost all sources. And you don't need to copy that data. The copy is not the main problem. It might be when you have very large data, but the main problem is the sync part. So data is changing and you need to sync that stuff. And when you don't copy that, you don't need to sync it because it's like automatically referenced. There is also a special case where shortcutting can help you when you need specific optimizations on the storage layer that, for example, Amazon S3 uses or a Google Cloud Platform and Azure not. Then it could be that you are faster with your data on S3, just as an idea, and then you can benefit from using shortcuts instead of copying the data to OneLake. But I think that's a rare case. So let's first create an internal shortcut. Very simple. I can create a new table shortcut, or I could even create a shortcut to a complete schema. But in this case, I will just create a shortcut to a table. I will pick OneLake, and I have something in the Copilot Workhouse, Lakehouse here. So let's see. You see there is the sales table most probably. Yeah, let's pick the sales table. Very simple. Next, and create, and basically that's it. We have our shortcut here. It takes some time to be displayed, but still, it's very, very straightforward because it simply uses my identity. Let's create a shortcut also to an external system in the next demonstration. So let's have a look at the capabilities in general. So you have this type of external shortcuts. External shortcuts could be ADLS v2. ADLS v2, you can do read-write. It works. Everything else basically is read-only. So S3, for example, is read-only. Google Cloud is read-only. Google Cloud is also read-only. And Dataverse is also read-only. All these external connections also store one credential, right? So you need to define the credential here, which means that when you have specific access for specific credentials, you need to remodel that later in Fabric. We have also the concept of internal shortcuts. Internal shortcuts. This is called OneLake shortcuts. For internal shortcuts, you have two benefits. The first one is you have read-write, and the second one is you have user identity. Oh, there you go. User identity pass-through. So the user identity is propagated within a Fabric, as you can expect, but also, of course, that makes things like permissions and the row-level security and so on much easier. Let's create a shortcut to a Google Cloud Storage. Very simple. I will put it into files because first of all, it's read-only, and secondly, it's a CSV. So I will pick create shortcut, and then I can go to the Google Cloud option. I have already a predefined connection, and I will explain you how it works. So this is the connection name. The endpoint is always storagegoogleapis.com because the specific storage account is selected via the HMAC key. This is similar to a storage key. In this case, it's account-based, so it's a storage key for this account. And you have two parts of it, just like in Azure. I have already defined it, so I need to hit cancel and open that again. So let's go. When I hit next, I could enable the caching for external shortcuts. So the range is between 1 day and 28 days. I will not do that in this case because, well, it's for demonstration purposes only. But when you don't do that, you have the ingress costs every time you hit that storage. So caching makes a lot of sense. I can select all the folder content, which is a CSV, employees, orders, and sales. So let's go. And I have the option to convert this automatically to Delta table if I want to, or I could import it as CSVs So I will first import it as CSV so you can see that. Takes a minute, and after a minute we will see the content of my Google Cloud storage directly here in Microsoft Fabric, which is amazing. So let's delete that and let's create the same shortcut again with automatic conversion. So I will pick again Google Cloud Storage, and I will still not select the caching option. And I will pick again the whole folder, and it's basically a next. Yes, the CSV is comma separated, and the first rows are headers. And then I can create that. Very, very simple. And after some time, we have the same folder here, but it's still working. And you have like the manage shortcut option here. And there you see there's a monitoring that hasn't even started right now. But after some time, we will see a status here, and it will do the auto conversion. And after that, we will have the Parquet files under our files section. And from there, I could use, for example, a notebook to create a table out of my Parquet files. One question might come up when we talk about external and internal shortcuts. The question is, okay, external shortcuts in most cases don't allow read-write. So they are like read-only. That's clear. But why then does ADLS v2 allow read-write? The answer is that the protocol is internal. It's an Azure internal protocol, so they can ensure proper read-write coordination. For all external systems, the problem is that you could have something like concurrent write and so on, and the Fabric cannot coordinate that, and for that reason, the stuff needs to be read-only. So there might come up one question. Okay, why is the external shortcut thing read-only with the exception of ADLS v2? So we have all this read-only stuff here, but we have read-write on ADLS v2. The answer is that ADLS v2 lives in the Azure platform. The Azure platform is tightly connected with the Fabric platform, obviously, so Microsoft can coordinate the protocol and ensure proper read-write stuff. For all the external storages, Microsoft cannot, so they have to provide read-only. The external-internal thing is fundamental to shortcuts. So you have differences between external shortcuts and internal shortcuts, also for authorization. So we have like external authorization for shortcuts, and we have internal authorization for shortcuts. Let's first have a look at the external authorization. For external authorization, we can have a user authentication, or we have can have an IAM key or SaaS token. The key is typically longer living and less secure, because if someone can steal it, you have longer access, basically, right? While SaaS tokens are limited in time and functionality. So these are both options to create a shortcut. To authenticate against a shortcut. Basically, this ends up in some kind of stored credential. And stored credential always mean everybody has to go cross the same bridge, which means individual permissions are abandoned because you use something which is more or less near to a technical user. So the result is all users have or share the same access level. This is in most enterprise scenarios I can imagine unacceptable, which means that you have to remodel the permission part in the target system, which is Fabric in this case. So you need to rebuild the permission requirements in Fabric. That can be hard, but you don't have to, because often you can get some permission tables or something like this from the source system, or you have the same group mappings that you use in Fabric itself, or similar group mappings or similar group inheritances and so on. So often it is more possible than it looks in the first place. So this is like external shortcuts. Let's talk about internal shortcuts. Internal shortcut authorization. The internal shortcut authorization is a lot simpler because you have a user. If the user is an internal user, means it's authenticated against Entra ID, and it is usually your own identity. With your own identity, you can authenticate against a shortcut. Then, and with the same identity, you can go same identity. You can go to the target Lakehouse. Which means in the end, the user must have access to both the source Lakehouse and the target Lakehouse. This is a story for internal authorization for shortcuts. This is internal shortcut authorization. Why do we have different models? Because for internal authorization, Fabric controls both ends. For external authorization, the external systems don't know Fabric users, so you need some kind of universal credential. And of course, for external authorization, that means a shared credential. So this is tricky, right? It needs to be resolved and architectured properly. Okay, so let's have a look how shortcutting works with Azure Data Lake Storage Gen 2. So first we need a connection. We can create a new connection, or we can use an existing connection. This is my Azure Storage, ADLS v2. I have a 2024 folder in there just to show it. So I can copy the URL. We need to use the DFS URL. You can do it manually like I did here. And then we can hit next. Pretty simple. We'll connect in the background. And now we can select and browse the folders that we want to include. In this case, you see I have CSV and 2024 folder. So I will include 2024. Let's hit next. I can select to transform my data automatically to Delta format. This is then done in the background. Honestly, pretty handy. When I do it like that, you will see it here. There's then the folder, and I can check with the properties of the shortcut that this is in progress, and I can hit refresh, and it will take some time until this workflow is up and running, and unless then we will not see any content in that folder, obviously. So you see it's still in progress. Now I've jumped a little bit forward. It took about, I don't know, 5 minutes or so, and we can see our files in that folder. When we refresh it, there you go. So this is the auto convert to Delta log in the files path of the Lakehouse. So this doesn't show up as a table. So let's create the same as a table. So basically we select the same connection, and we will select the same folder. We're very simple, very handy. You see the same folder, the same storage account. This is the content that says CSV. I cannot select the cell CSV directly. I have to select the folder. I will do that. and hit next, and then we can again select whether there's an auto transformation or not. The auto transformation is in this case automatically applied because we replicate that, we shortcut that to the tables folder. We can rename the table here, so we will do that and rename it to the sales table, because the CSV will be converted, as we have seen before, in place in the Delta format. And this is important because then the folder name essentially becomes the table name. So because we have already a sales table here, this is sales_1, well, that's fine. We can refresh that. You see it is currently again in the progress of replicating and converting. You have again the manage shortcut setting, and you see this thing is still in progress. So it's running for some time now. It succeeded. I cut it off. And now just have a look. So it's an unidentified folder. There's a shortcut at the moment. And we can hit refresh in the folder, and we will see the Delta files and the Delta packet files. And when we hit refresh on the unidentified folder, everything is auto-recognized, and it's automatically mounted in the Lakehouse as a table. This is the magic, and don't get it wrong, or don't think that it didn't work. It works. It works perfectly. And you just have to wait until the shortcut process conversion finished, and then you need to hit refresh on the unidentified folder, and everything will rock in place. And you see now, because everything is cold in the cache, it takes some time to load, but that's fine. And this time I can explain the stuff to you, but after some seconds you will see this is the table content. So let's have a detailed look at the shortcut placements inside of the Lakehouse folders. Here's the overall Lakehouse. And we have two different folders inside of that Lakehouse. The first one is the files folder. The second one is the tables folder. Lakehouse, files folder, tables folder. Inside of this files folder, I can do more or less anything. So I could put subfolders here, for example, staging. I could link then external stuff here. Shortcut. I could, so there's like a subfolder here. I can link raw data. It's like a file system for me, very simple. The tables folder is more complicated. Tables folder doesn't accept subfolders. Is nested files. This is not possible, not acceptable. I could link data formats directly with a shortcut inside here. And I could, of course, create tables out of files. So all that will work. Different shortcuts without subfolders and tables directly created. So when we sum this up, so this means on the left side files anywhere allowed, any format, but manual load. You need to load the data manually. Manually means usually notebook. When we sum up the tables folder, there is top level only. Top level only. You need delta format. There's an auto conversion now that you can use. And then the benefit is the data is auto discovered. That's a great thing. Once you do it right, your table is automatically discovered. the Lakehouse. So why all these restrictions in the tables folder? Well, the point is the Delta Lakes transaction log is discovered as at tables, name, and then Delta log. A nested shortcut breaks this pattern, and you cannot also have not spaces and special characters in the names, of course. So this is mostly given by Delta table naming restrictions. Let's have a look at the caching flow with an example of an S3 bucket. So what exactly does happen when we select the cache option in the shortcuts dialog? So let's say we access the data from a Spark notebook. This is our Spark notebook. And the Spark notebook, let's draw a long line here, makes the first access. And the first access means cache miss, because it's the first access, obviously. So we have the next touch point is the OneLake. Draw it here. It also a line like this one. So this is the first access, which means read file. From the OneLake, and the OneLake then is checking the local cache. That's the next touch point, local cache. So OneLake is checking the cache. Check the local cache. And the result is miss, because it's the first access still. So that means we need to fetch the data from our S3 bucket. So this is our S3 bucket. It's external. So OneLake needs to fetch the file from fetch file, which means costs for ingress data. So data is returned. All good. Into OneLake. And OneLake stores a copy. So data returned. And OneLake then stores a copy in our local cache, obviously. So now, well, and the data is returned back to our notebook. So next request. Second request. Now we have a cache hit. So like that. Second request. Second request. There we go. So we have again the read file. Read file. We have the check cache. We have this time a hit. And the data is then returned. So this is like notebook, right? This is OneLake. And this is our local cache. Local cache, OneLake, notebook, just to make it clear. There we go. We have a hit from the local cache, and the data is returned to the notebook. Return from cache. No ingress. No dollars here. So that's how the cache workflow works, and that's a benefit, of course, when your data updates. You cannot use the cache anymore, so this is why you can select the caching time. So what's about the 5-hop restriction? So we have a limit on shortcut chains. So let's say you have a Lakehouse A, and from this Lakehouse A, you have a shortcut from Lakehouse B. This is hop 1. From there, you have a shell shortcut for the same data from Lakehouse C. This is then hop 2. And from there, let's say we go to ADLS v2. This then is hop 3. That works. This is fine. When you would have more hops, like hop 4, hop 5, and hop 6, this will not work. So limit is 5-hop limit. Why? Because of latency. Each hop adds latency, as you can imagine. There's always some kind of latency on top. There is a potential failure point, and there is a security check with adds also some work. So this again is for latency, but it's also for circular reference loops, because when you imagine a 100-hop chain, the possibility is there that you link back and forth, and you don't even have a clue on that, and just think about the deployment and development and debugging nightmares and cascading errors and so on. So finally, the question is like when to copy and when to shortcut. So shortcut versus copy. This is a decision framework, right? So first question is your data in an external location? For example, S3 bucket, Google Cloud, you name it. Yeah. So if yes, just let's draw a Y, makes things easier. If yes, there we go. If yes, then the next question is, do you need to write data? If yes, then is it ADLS v2? If yes, then the decision is very clear. It's shortcut, because you can read-write. That's cool. Done. If it's not ADLS v2, no, then you need to copy the data to Fabric. If you don't need to write, let's say no need to write, then the next question is your source reliable? Can you access it in a reliable way? If yes, then you can go with a shortcut. This is then read-only, but it's fine because you don't need to write. If the source is not reliable, then you need again copy data. If your data is not in an external location, things are very simple. Use the internal shortcut, which is in OneLake shortcut, and everything is fine. This is basically our decision graph. Data in external location, yes, no. If yes, if you don't need to write and the source is reliable, go with the shortcut. If you need to write and you have ADLS v2, go with the shortcut. In every other term, go with copy data. Let's have a look at the community questions. First and foremost question is always, can I write to an S3 storage via shortcut? Or more basically, when I try to write a data frame to a shortcutted S3 storage, I will get an error. Is this a bug? No, this is by design. S3 shortcuts are read-only. Here's why. Delta Lake needs to manage the transaction log for reliable writes. S3 is an external storage without Delta Lake's transaction coordination. If Fabric allowed writes to S3, you couldn't end up with partial written files with conflicting updates or with corrupted data tables. Microsoft made the safe choice. Read from anywhere, write only, where we control transactions. Workaround is use the Spark notebook to read data from S3 shortcut, transform, and write to a native Lakehouse table. Next question. Why is my S3 shortcut so slow? This is from Reddit. Queries on my S3 shortcut take forever to native Lakehouse tables. What I'm doing wrong? 3 most likely causes. First one, cross-region latency. If your Fabric capacity is in West Europe, but your S3 is in US East 1, every query crosses the Atlantic. Check the regions. Second one, many small files. S3's charges per request. 1,000 small files, 1,000 API calls. Consider pre-compacting your S3 data. Third one, no caching enabled. By default, every query fetches fresh from S3. Think about the Atlantic. Enable workspace level caching, then the thing will go faster. Question 3. Source shortcuts disappear after renaming the source table. I renamed a table in my source lakehouse, and now the shortcut in my other lakehouse is broken. Why? The answer is shortcuts are path dependent, not ID dependent. When you create a shortcut, it stores the full path. When you change the path, obviously the path breaks. The shortcut still points to the old location. Why? Because Fabric follows the symbolic link model. Just like a Windows shortcut breaks if you move the target file, OneLake shortcuts work the same way. Solution: delete and recreate the shortcut pointing to the new path. Avoid renaming tables that have shortcuts pointing to them, or use a naming convention and stick to it. If I create shortcuts to 10 terabyte of external data, does that count against my OneLake storage? No, shortcuts are just pointers, metadata essentially. The actual data stays in the source location. What does count as native Lakehouse tables you create, files you upload to the files folder, cached data if you enable shortcut caching. So if you enable caching with 28-day retention and frequently access 500 gigabytes from your shortcuts, that 500 gigabyte will count against OneLake storage. I want to create a shortcut to a lakehouse in another team's workspace. I can view that lakehouse, but I cannot create shortcuts to it. You need at least, the answer is, read permission on the source item, and the source workspace must allow external references. For OneLake shortcuts, your identity is passed through. The security happens in 3 places. First one, your access in your lakehouse, where the shortcut lives. Second one, your access to the source workspace. And the third one, your access to the source item, lakehouse, warehouse, where you want to point the shortcut to. If you can query the source lakehouse directly using the SQL endpoint, you should usually be able to create a shortcut from a permission point of view. Next question. How do I set up S3 shortcut with role assumption? My company uses IAM role assumptions for S3 access, not static keys. How do I configure this for Fabric shortcuts? The answer is currently Fabric S3 shortcut support IAM user with access key and secret key, S3 buckets with SSE KMS encryption with proper key permissions. IAM role assumption is not directly supported for shortcuts. You could create an IAM user specifically for Fabric with minimal permissions and use that. That would be the workaround. Next question. I created a shortcut to an S3 bucket with target files. I can see it in the Lakehouse Explorer, but it doesn't appear in the SQL endpoint. SQL Analytics endpoints only discover delta tables in the tables folder. Why? The SQL endpoint needs schema metadata. Delta tables have that in the _delta_log. Raw packet files don't have a discoverable schema. Solution is if your source is in delta format, shortcut will appear in SQL endpoint. If your source is raw packet, you spark to query or create a shortcut in the files folder, convert, read via Spark, write as delta table to the tables folder. Some tips and tricks. Bronzy layer pattern. So we use shortcuts exclusively in our Bronzy Lakehouse. All raw data stays in ADLS S3, silver and gold are native delta tables. This keeps our source systems as a single source of truth while enabling Fabric analytics as one best practice. I think that's a good point, to be honest. Next best practice. For S3 shortcuts, we rotate IAM keys quarterly. Create new key, update shortcut connection, delete old key. Test the shortcut after each rotation. This will make your security officer very, very happy. Next tip is monitor shortcut health. Set up a simple notebook that runs daily and tries to list all the files from an external shortcut. If it fails, send an alert. Shortcuts can break silently if your source permission changes or if the path changes. Next one is naming conventions. This is also reflected in the Fabric periodic table. Prefix all shortcuts, for example with SC, make it obvious at a glance which is a shortcut and which is a native table. Some sentiments. So a lot of people are doing cross-workspace sharing with shortcuts. Next most used is S3 shortcutting. The biggest challenges are the read-only limitations to external storages. For attending, we learned, I think, a lot about shortcuts. We have seen a bunch of demonstrations about shortcuts. When you want to get informed the next time I release a video, hit subscribe and hope to see you next time.